Welcome to this brief but important explanation of a critical phenomenon in structural engineering, buckling. You've probably heard of structures collapsing unexpectedly, and in many cases, buckling is the hidden culprit. So, what exactly is buckling? Why does it happen, and how do engineers prevent it? Over the next few minutes, we'll explore these questions to uncover the dangers of buckling and its role in structural failures. What is buckling? Buckling occurs when a structural element, like a column or beam, suddenly bends or twists under compressive stress. Imagine holding a long, thin ruler upright and pressing down gently from the top. At first, it resists the force, but at some point, it bends to the side. This is buckling. In real structures, this can be extremely dangerous. Columns in buildings or bridges are especially vulnerable to buckling when they are subjected to too much weight or force. Why does buckling lead to collapse? Buckling is dangerous because it often happens without warning. When a structure buckles, the load it was carrying can no longer be supported. For example, in a skyscraper, if a column buckles, the entire weight of the building above that point may no longer have the proper support, leading to a rapid and catastrophic collapse. This is why buckling is one of the key failure mechanisms that engineers must consider in their designs, especially for tall buildings and slender structures. Critical load, the tipping point. So, what determines whether or not a structure will buckle? Engineers calculate something called the critical load, which is the maximum load a column or beam can handle before buckling. This depends on several factors, like the material, the length and shape of the element, and how it's supported at both ends. Once the load goes beyond this critical point, even a tiny increase in force can cause sudden failure. That's why understanding critical load is essential for designing structures that can withstand compressive forces. Preventing buckling in structural design. To prevent buckling, engineers reinforce structures by adding bracing, using stronger materials, or making columns thicker to resist compressive forces. Sometimes, reducing the length of the columns or providing better support at the base can also minimize the risk. By understanding the causes and effects of buckling, engineers can create safer structures that won't fail under unexpected loads. Conclusion. In summary, buckling is a silent but severe threat in structural engineering. When a structure buckles under compressive stress, it loses its ability to support loads, leading to potential collapse. By carefully calculating the critical load and designing to prevent buckling, engineers ensure that buildings, bridges, and other structures remain safe and stable, even under heavy loads. Thanks for listening, and remember, structural safety is all about understanding and preventing failures like buckling.